So, as you might have guessed by the title, this talk is about Kotlin. Who here has ever actually worked with Kotlin? Oh, a lot of you. So, I guess you may be slightly disappointed. This is mostly an introductory talk, just mostly targeted towards Java developers and to show you what is Kotlin and how it actually differs from Java. I'm guessing that everyone here has used Java, because otherwise you'd probably be on the wrong place. Well, and what is actually Kotlin? If you actually take a look at it and just look slightly under the wraps, you'll see that it's pretty much the good old Java you're used to, with some eye candy and a few extra improvements that will make your life much easier. We have been using Kotlin here at Talkdesk in production for a couple of months now, and it's been a great experience. Most of us who have worked with Kotlin have worked with Java before, and I think it's something consensual that Kotlin makes you much more productive. So, what actually is Kotlin? It's a JVM language designed by our good friends at JetBrains, and it's the language one of the languages that they use to build their tools, the IDEs, the team CD, their issue tracker, and all that. Just like Java, it's an object-oriented language with some flavor of functional programming, and because everything's functional programming nowadays, otherwise you're not Gibson. Like I said, just like Java, it's statically typed, but unlike Java, it doesn't target only the JVM. Currently, they are targeting mostly good old JVM as we're used to. They're targeting Android. It's gained a lot of traction among Android developers because it only targets Java 6, which Android supports, and brings you a lot of the niceties that newer versions of Java actually give you. And it's still somewhat experimental, but they also target JavaScript. So if you like Clojure and you like saying, oh, I write Clojure for my backend and my front end, they want you to be able to say the same about Kotlin. If you haven't tried it, I highly recommend you go to this website, try.kotlinlang.org. It basically gives you this nice web UI where you can see multiple examples of the language, and it's a very good way to start experimenting with it. If at least one of you comes out of this talk and is willing to go try this out, I'll consider it for me. What's the big philosophy behind Kotlin? Because I mean, the guys at JetBrains, their business is building tools. The tools that we use every day. Their business is not exactly developing programming languages. They're not Oracle. So what's the philosophy behind it? What's the reason that they wanted to develop something new? Well, of course, they wanted you to be more productive, just like pretty much every other JVM language tries to. But unlike other JVMs, it tries to be pragmatic. Unlike other JVM languages, it tries to be pragmatic. It doesn't try to solve all the world's problems. It basically tries to make you a more productive developer. It looks at the biggest pain points that you as a Java developer face every day, and they try to make it better for you. They try to ease the development. It's a concise language. I know that at this point it's pretty much a cliche to say that Java has a lot of boilerplate and it's verbose and whatnot. And we all try to go on the defensive there and say, oh, that's not really a problem. The IDE generates most of that for me. And that's true, yes. But as you use Kotlin, over time, you like the conciseness. I'm not even sure that's a word, but you start to enjoy the things that you don't have to do and all the boilerplate that you don't need. It also tries to be a safe language. The way the language is designed and the way the type system works, it tries to avoid the biggest mistakes that Java programmers usually do. One of the big things that they try to tackle is the classical null pointer exception. It's not exactly foolproof. It can still happen, but it makes it much easier to avoid those errors.
Yeah.
After running a few months in production, I've never seen a single null pointer occur in our production systems. And it also tries to be interoperable, because in both ways, not only in the sense that you can easily invoke Java, but also in the sense that Java code can easily invoke cases. You might ask, well, is that really necessary? If my project is in Kotlin, do I really care about Java code being able to invoke it? Well, if your whole project is in Kotlin, probably not. But what this means is that it makes it much easier for you to pick your big project and just start migrating it to Kotlin. There are multiple examples of blog posts you can find online of people who actually started moving their huge projects to Kotlin literally one class at a time. Each time they deployed their application, one of their classes was changed from Java to Kotlin. And this principle is embedded in the core language and in the language's design, and it's something that they really strive for. And of course, no language is complete without a proper set of tooling. And being JetBrains a tooling company, of course, they focus heavily on the tooling around Kotlin. They, of course, built the Kotlin plugin for IntelliJ that's just built in nowadays. But they also built the Kotlin plugin for NetBeans and Eclipse, and I think they're releasing one for Atom. Not entirely sure, but they're the ones who are leading the NetBeans and Eclipse projects. So they're really focused on the tooling, and they really try to make sure that you can use all the Java tools that you use now every day with Kotlin projects in a very seamless way. The language itself is also quite lightweight. If you go to say Scala or Clojure, you look at the runtimes, that they're huge. They have a lot of stuff. They make startup pretty slow. If you look, for instance, at Scala, it actually has a pretty slow startup time because of all the stuff that's in the runtime. As most of Kotlin is let's say done at compilation time. Most of what the language does is just resolved in compilation time. It leaves a very thin layer to runtime. I've looked at the compiled versions of the projects we have here at Talkdesk, and most of the Kotlin runtime invocation is just intrinsic null checks and type checks that the Kotlin compiler makes invisible to you, but that it injects into runtime to ensure that even if you call your Kotlin code from Java code, you get the same semantics within your code. Even if just by throwing a null pointer exception and a method that does not expect a null to be received. Well, this is all very fine and dandy, but I haven't actually shown you anything about Kotlin, so what the hell am I talking about? Well, we've all seen something like this, some random hello world example. I'm very imaginative with those examples. This is the plain one you find in Java, well, everywhere, from university books to every tutorial. This is the same thing in Kotlin. Unlike Java, Kotlin has top-level functions that don't need to be declared inside of a class, although they clearly document how that is actually achieved, so that even if you want to invoke this function from Java, which always requires you to invoke something in the context of a class, they their documentation clearly says how you can do it, even for this top-level function. If you look at it, well, it's not that different. Instead of public static void main, it's a fun function. There's a lot of languages that do the same thing. The arguments are the other way around, and that's pretty much it. It's not. Is anyone shocked by this hello world? No, because it's actually something pretty simple.
It looks fun.
It looks fun. It is fun.
You're missing a comma. Hello, comma world.
You got me there. Bonus points for you. The first thing I actually want to talk about on the more practical side of the talk is about types. How Kotlin handles types. Once again, this is some example of a method that receives a person and prints that person's name. If you try to pass a null there, well, anyone who doesn't know what's going to happen, kaboom. It's gonna blow up in your face. You're gonna get an error introduction, and you're gonna be sad. If you write the same exact code in Kotlin, this is just a simple function that receives a person and prints the person's name. That dot name is Kotlin's syntax for accessors. You don't have to do get name and set name. They have just this simple syntax as well in many languages do nowadays. What happens if you try to invoke this function with a null? Well, you get a compile time error. Because you're not saying that this function, you're saying that this function receives a person, and you're trying to pass something that's not a person, because, well, null is not a person, null is nothing. If you wanted a version of this method that could receive a null, you would have to declare the person question mark type. This way, the compiler both knows that this method can receive either a person or null, and it knows that that within the method, it's not safe to invoke methods or to access properties of that object because, well, it knows it might be null, it might blow up in your face. So it requires you to do something. You can, for instance, check if the instance is not null. By doing this check, the Kotlin compiler is smart enough to know that within the body of the if, that instance can never be null, because otherwise you wouldn't get inside that branch. And then you can just work with your person instance just like you would in Java. This may seem like a trivial point, but it's actually a very powerful feature of the type system. And it makes your code APIs much easier to work with. Well, first of all, because they're self-documented. You explicitly say which methods may receive null, which methods may not. And the same works for return types, because you can either return a person or I'm going to call it nullable person. And you know out of the box what you're going to get out of that method. Primitive types. I don't have a slide to show this because, well, Kotlin pretty much just ditched primitive types. They only have what we in Java know as the box versions of it. But that's actually just an abstraction, because deep down, whenever the Kotlin compiler can determine that, for instance, you receive an int that's never nullable, within the VVM it just uses a primitive int. But for you, you don't have to worry about dealing with the two objects, and you don't have to worry about the automatic cast, because I'm forgetting the actual word for it. Boxing. Yeah, the autoboxing. You don't have to worry about it. And plus, there's no automatic widening or coarsening of types. So if you have a method that expects a long and you only have an int, you have to explicitly say that you want to convert that into long, or vice versa. It doesn't do some of that widening that sometimes creates weird bugs when you're working with pure Java. The other major difference in the type system is how it handles arrays. In Java, arrays are always that weird thing that even the VM treats in a special manner, and that is something that's always very weird. The casting rules are weird. The way you actually use them are weird. So they just ditch that, and once again, they just treat an array like a regular class that just has a get and set method, which then lets you use the bracket notation you usually use with arrays. Deep down, it's still going to be backed by an actual Java array, but it gives you a much nicer API to work with. It's just pretty much the same as if you had either a list, From your perspective, it's pretty much the same thing. Now, let's see how you deal with it in your code, which is pretty much what everyone always uses. This is Java, as you might see. You declare a name variable of type string, whose value is Kotlin, and you declare it as final, so that you know that you're never going to change that variable within your method. Then we have an age variable that's not final, so a few moments later we can just reassign the variable. In Kotlin, this is slightly different. First thing is that you drop the semicolon, thank you even. And instead of having to declare if a variable is private or not, you always have to declare that a val or var. A val variable, it's something that will never change. Within that method, you can never change the value of name. Var, well, it's the same thing as a non-final variable. This might seem weird at first, but after you get used to it, it's a matter of discipline that you always know what to expect of your variables. And as you can see, the variables that are right there also have types attached. We are all used to that in Java, but the guys over at JetBrains thought, we know that Kotlin is a string, so why do we need to say that this variable is of type string or that age is of type int? So they just decided to drop it. I believe that in Java 10 they're trying to do something similar, finally. It's going to be out probably in 2020, but they're going to catch up to 10 years ago in language design. So you can just do this and don't worry about types. It will be smart at inferring the types of the variables. Functions and expressions. You already saw the syntax for finding functions. This is just a simple function that takes two ints and returns another int that's the maximum of those two. And this is pretty much the same thing you write in Java, other than the first line. But Kotlin lets us do some cool stuff. In Kotlin, for instance, if is not just a control flow construct. It's actually an expression. So instead of doing if one bigger than another, return one or return another, we can just say return and the actual value of the if, because if itself is an expression that's always evaluated to the last statement on the corresponding branch. There's also one more peculiarity about this function is that if you do this function is reduced to a single expression. You're just returning the value of that if expression. And Kotlin lets you simplify that by saying that instead of having the brackets around the method and the return type, you can just say that function max equals and the actual expression. This is what it's usually called the one-liner notation. Allows you to create very, very compact methods, especially when you're doing some simple stuff like just returning a field or a property. But there's also there's still something we can improve in this function. Both one and other are ints, and we always are returning an int there. So why do we really need to specify the int return type? Well, the answer is, once again, we don't. And we can simplify this function even more. And if we actually want to go to take the extreme on the one-liner notation, we can just do this. They don't have a ternary operator. They're still debating on whether it's a good practice to include it in the language or not, but for now they don't have it. So this is the compact version of that function. Any questions so far?
It's very much like Scala that you showed.
Without all the other bloat of Scala.
Yes.
Kotlin also has some other operators, some that you recognize from Java, some that you don't. The first one is the when operator. This example right here is similar to good old switch case you find in pretty much every language, with the exception that you don't need all those break. You can just specify it like this. It also has some other nice properties. Is that instead of just matching on the actual value of x, you can ask it questions about x. You can do, for instance, when x, where x is of some type you don't know. You can do when x is a string, do something. When x is an int, do something. When x is something else, do something else. And it always requires you to either fill all the possibilities of when. So if, for instance, you have an enum, you can just enumerate all the actual values. But if you don't know all the possible values, you're always required to have this else branch. Why? Because just like if, when is also an expression. So if you use it as an expression, it must always return something of some type that you can use usually to build those one-liner functions. One other
One question about the when. It's possible to, in the default clause, to do pattern matching with anything instead of declaring the else?
Sorry, can you repeat that?
Yeah, it's possible to do pattern matching for any value.
Not in the same way that you can in Scala or Elixir or something. This is this is a simpler construct. It's just based on Boolean values on the left-hand side. It doesn't give you more powerful stuff like it does in Scala, but it's still more powerful than the good old switch case that we know from Java.
Okay.
So no deconstruction.
No. The safe navigation operator. We've all written something like this. We receive, let's say, a person argument. We want to get the person's name, but the person might be null, and in that case, we want to return null. Who here hasn't written something like this? Kotlin gives you what they call the safe navigation operator. It receives something of type nullable person. You can use the safe navigation operator on something that's not nullable, but well, it's pointless, and the IDE will give you a warning saying this doesn't need to be here. What this does is that if person is null, it just returns null. That's why the return type of this method has to be nullable string. But if person is not null, it just returns in the name. This is also a pretty common operator in other languages, and it allows you to create some very expressive expressions, which combined with another operator I'll show you in a few seconds, allow you to do some really powerful stuff. The other operator is this one called the Elvis operator, because the operator itself looks like Elvis's hair. And what it does is that it gives you either, in this case, we're combining the safe navigation with Elvis. What this gives you is that if person is null, the person.safe navigation name will return null. So the Elvis operator will say, oh, instead of null, I'm just going to give a null. If person is not null, or if name is not null, because if name is null as well, it also falls on this clause. If either of those are null, it gives you unknown. Otherwise, it just gives you the value you want. This is cool for more easily dealing with nulls and providing default values for your variables. But this is something that we have found out that we use this more often when dealing with Java interoperable code than we actually do when dealing with pure Kotlin code. And I'll show you, you'll see why just in a moment.
Isn't that an OR?
Sorry?
Isn't that an OR? Or the OR needs to have Boolean values?
Your needs to have, are you saying your, like for instance in Ruby?
Yes.
It's pretty much the same thing, yeah. But
This
this,
can use an OR there because in Kotlin an OR needs to be between
yeah,
Boolean
it
values.
needs to be Boolean, and then like with Ruby and JavaScript and all that, this only works with null. Doesn't work with full Z values. This is only for null. Another cool operator is, well, it doesn't have actually a proper name, so I just call it what it actually does is SmartCast. Let's say that you have a method that receives any is a Kotlin's object, because they have to change everything, of course. Every language in the new type system has to change everything. So what you do if you receive an any is that you can use that is operator. This is basically the equivalent of instance of. But unlike in Java, if you do an instance of within the body of the if, you don't have to actually make the cast within that branch of the if, because it knows, oh, this branch will only run if any is actually of type string. So it just assumes that any is string. So it just lets me do any.length. That's a method that's only available on type string. And on the contrary, if it isn't, well, it just lets you do more any's. This is also something you can combine with the when, like I showed you earlier. You can do when is string, is int, and all that. This same SmartCast applies to that operator. And this is how you cast something to, well, you directly cast something to another type. Just like in Java, this will work, but will give you a compiler warning because it says, whoa, this is an any and you're just assuming this is a string. You should be careful because if this is not a string, I'm going to blow up, and it does. So it gives you, so Kotlin gives you another nice operator. It's that as question mark. And what that does is that if any is of type string, the variable as string has the value of any casted to string. But if it isn't of type string, it just gives you null. So the actual type of as string is a null string. So what you can do here is that if as string is not null, you can just ask its length. Otherwise, you can just say, oh, it's a null because this is not string.
Do you find that you get many insecure programmers that don't know anything? Is it a string? Is it a length? Is it null? Is it?
You'll find that
You can use any and then just put the little question marks everywhere and it will compile.
yeah.
Didn't you miss visual basic?
Sorry, I'm not from that type. But what you actually find is that you don't really have to do this stuff. This is just to show off the operators, and it's a contrived case. I just wanted to kind of jam everything here so you can see how everything goes together. But this is not something you actually see in practice. Any questions so far? I gotta speed up because it's getting late. So this is an object-oriented language. So of course there have to be classes. Well, this was disappointing. This is a good old class in Kotlin. The main difference from Java here is that everything is both final and public by default. In your projects, you'll find that probably most of your classes are public anyway. You just have to write everywhere, public class, public class, public class. So they decided to optimize the default. So the default is public. You can just get there and write not entirely sure if you can write protected, but you can just get there and write a private class. And everything is final by default. If you want to make sure that your class can be subclassable, you need to explicitly open it. And the same applies to the methods in that class. If you don't specify anything, you just can't extend it. It's final. Constructors, they are not that different from Java at the first glance. The syntax may seem a bit weird at first. You just declare the constructor up there, the parameters of the constructor up there, and then you declare its body in this init block. This is the most one-on-one match to Java, but it's something that's not that common because there's better ways of doing this. Just like in Java, you can have multiple constructors. Kotlin has that concept of the primary constructor, whose parameters are passed right along the class. And every secondary constructor has to delegate to the primary constructor. That's what that semicolon this name means. Even if you have other constructors, they always have to invoke the primary constructor of the class. In Java, the empty constructor is the closest thing that you have, but it's not something that you really control, and it's not something that every class has. That's why things like Spring, if you want to do constructor injection and you have more than one constructor, you have to specify an auto-wire to have it inject parameters. In Kotlin, well, that doesn't work yet, but on Spring 5, they will actually have the notion of the primary constructor and just inject stuff there. Inheritance. It works very similarly to Java. As I said earlier, you have to declare your parent class open, so otherwise you just can't extend it. And this is the syntax you have for saying that your class foo extends that class part. You have to always specify what's the constructor that you want to invoke on the parent class, because once again it can have multiple. In this case, the primary constructor of bar has no argument, so you just say you call the primary constructor that's the empty one. But you always have to invoke one of the constructors of the parent class here, because this is how the primary constructor of your class will work. If you want to extend an interface, to implement an interface as opposed to extending the class, the syntax is pretty similar. You just drop the parentheses. There's no distinction between the extend and the implement keyword. It's pretty much all the same thing. Kotlin doesn't really have the concept of fields of a class. Just like, for instance, C#, it has the concept of properties. You say that your class, in this case poor, has a property called name, and you initialize it with the constructor parameter. This is quite similar to what you do in Java. But Kotlin actually gives you a nicer syntax for this. It allows you to at the same time declare the parameters of the constructor of your class and the properties of your class. What this says is that your class has a private property called name that can only be accessed from within the class, and it's required on the primary constructor. So you don't have to go through all that boilerplate of declaring the field, declaring the constructor, ensuring that you properly initialize the field. Kotlin just takes care of that for you. Of course, that once this is compiled to Java, that is exactly what it does, but at least you don't have to write it, and you don't have to look at all that boilerplate all that. Properties don't need to just be backed by fields. You can override either the get or the set method. Just like variables, you can have properties that are read-only, that can only be defined in the constructor, and you have properties that are both read and write. On the read-only, of course, you can only extend the get method. On the other ones, you can extend both get and set. In this case, I'm just extending the get method to print that, hey, I'm doing something. You can also say that you have a mutable property but that you only want it to be mutated from within the class. This is the syntax that you have to use. You just declare the property as public, but you then say, no, the setter is private, only I can invoke the setter. It also has this nice concept of delegated properties that I'm just going to glance at because it's getting late, which allows you to automatically delegate both the get and set methods to other objects. One nice example is that lazy thing that they provide here. What that lazy is an object that's given by Kotlin's standard library that ensures that in a thread-safe way, the first time the get method is called, it will lazily run that code. So only the first time that you actually do a get on that property will this be computed. And this is done in a thread-safe way. It ensures that this is only run once, and that after it's initialized, you just access it as a normal property. Just gonna pass through this. Wait. There's also extension functions, which allow you to declare functions of other types. This is somewhat cheating because it doesn't actually change the other type. What this actually does when I do string.lois, what it actually does is that it just creates a static method that receives the string as the first argument. And whenever I do world.lois, the compiler replaces that by the invocation to the static method. This allows you to just better chain your extension functions. And most of the Kotlin standard library is actually just extension functions. It just has nicer methods. For instance, everyone here has used collections.sort. They use extension functions to add a sort method to list, for instance. They also have this concept of data classes.
Sorry, can you go over to the previous slide? So, this remembers me something that was called prototype before jQuery appears. What happens when the object string implements the same method you are?
Unlike in JavaScript, if this function is not declared in the same compilation unit as you're using it, you have to explicitly import it. You actually import the extension function, and if string already declares this LOIs thing, if you don't import it, you're using the prototype version. If you import it, you're using your version.
But if you try to
if they
define
clash, if there are two LOIs,
Sorry, what do
you
you mean?
import another LOIs.
You can use. Actually, I'm not sure if type aliases work for this, but they allow you to do type aliases on imports. So if you import two classes with the same name from different packages, you can give them different names. I'm not sure if this works there, but it's a nice exercise. But this is mostly to just add extra functionality to existing classes. This is not to replace the core behavior of classes.
But the thing is, you extend it some way, and the other guy that you import extends it, had the same idea, uses the
going to
same
give you a compilation error.
Okay.
Saying that it cannot determine which one you want to use. And to be honest, I'm not entirely sure how you can do it. Because I've never actually hit that. Okay, so data classes, you've all written something like this. Good old Pojo probably to use for JPA or for other mapper. Once again, you have to declare the fields, you have to declare a constructor, you have to declare declaration setters, you have to declare equals and hash code because of course, and the IDE generates this for you, so there's no reason to not do it. You have to declare toString. And well, this is a lot of boilerplate for something that you probably have tens or even hundreds of in your code. Your model, as the project grows, your model becomes bigger and bigger, and you start having more classes and more properties, and this becomes a bit of a maintenance hell, and well, it just becomes a lot. Kotlin just simplifies this by giving you the concept of a data class. The only difference between a data class and a regular class, it also has the properties that you declare in the constructor, but the data class gives you two niceties. It implements all the equals hashcode and toString methods with some same defaults that of course you can always override. And it gives you the nicety of properties that you can just access those properties easily. And well, this is how you build a data class. How you instantiate a data class, just the same way you instantiate any array.
So why don't you always use a data class? So why do you need to put data? What's the downside of the data class?
The data class is mostly used to just specify the model. You don't implement equals and hashcode on every class that you build, only on the POJOs or model classes that you create. Usually the same rule of thumb applies here, but there's not really any big downside to it. Just, well, compile code gets you. That's pretty much it.
So, when you compare data objects, you compare it by reference or through equals?
The equals operator in Kotlin works the same way as the equals method in Java. So it's not the reference operator as it is in Java. And it pretty much does that for the whole thing. It just checks if the other thing is also of that person and if the properties are equals on each and every one. So it basically does what you want it to do for your model classes. But the example I showed you here, we're using var, so these properties are mutable. But what if you want to have your model immutable? What if you don't want to be doing sets all the time? If you're working in Java, you have this variant or this pattern where you do with property, where you just create a new instance of the class, invoke the constructor with every other parameter the same, and just pass the value you're given to the correct parameter. Well, this is a mess because once again, instead of writing set name, you have the with name for every property, and it quickly becomes a lot of boilerplate. So in Kotlin, what you just need to do is that you change your vars to false. They act just as read-only properties. And what you do is this. A data class also synthesizes this copy method, in which you can just specify I want another copy of this object with this property change. And you can pass multiple properties, you can pass only one. And it gives you a new instance of John of person with only those properties changed. It synthesizes all that for you. All of that is given to you for free. And with this, there's pretty much no reason to not make your models immutable. Every model that we have on our Kotlin project here at Talkdesk is immutable because, well, it's just so easy to do this, and there's really no big reason to not do it. Unless you're in one of those places where you have to be sub-millisecond and every memory allocation counts, but it's probably not the case for any of us. As you saw in this example, methods can have named arguments. Have you ever had a method with a lot of arguments that you just keep track of which argument is in which position, especially when you're using some library with a method with say 10 parameters, it easily becomes unmanageable. And well, I really don't want to deal with that.
And sometimes instead you have to put a stupid object or a class that it's just worth to pass the parameters, which is also silly.
Or you have to do those cases where you have to do string and null until you get the actual argument that you want. And it's a mess. Kotlin gives you named arguments by default. The names of the arguments that you give in your methods, they are exported like this instead of You can mix both ways using indexed arguments and named arguments. For methods with a small number of parameters, it's fine to just use indexed arguments, but as the number of arguments increases, this becomes really, really useful. And well, this is actually what is used in that copy method. You just synthesizes the copy method with every possible property and lets you just override only the parameters you want. It also allows you to give default values to methods and constructors. This is an example from Spring Security, where you have 3 constructors from the same class just passing default values. We've all seen something like this. What Kotlin allows you to do, as many other languages do, is to specify the default values for every parameter. This, coupled with this definition of primary constructor, means that you pretty much never have to create multiple constructors unless you really want to do something different in the body of your constructors when the types are different, but that's probably just a pattern that it should really be the same entity. So this is a really powerful solution. In this case, I forgot to put some usage example here. What you can do is that you can, as we have default values for both parameters, you can just say, oh, I want to create a new beeper password encoding, just with the default values, or I want to override any one of those properties, or both. And as you can see, one of the default values there is not a constant. What that does is that every time you invoke this method or constructor, it runs that piece of code. In this case, it creates a new instance of secure random, because you might not want to reduce the thing. So you can have some pretty nice defaults there.
Is this available if you try to instantiate normal Java classes?
No.
Can you figure out?
No, this only works for Kotlin classes. At least for now. I'm not sure if it made it to the 1.1 release, but what they're working on is adding support for the optional parameters metadata that they added to Java 8. And when that is enabled, and when that release of Kotlin is out, you can do that for those Java methods. But rule of thumb, well, you're powerful.
Joe, can you go back, please? No.
Here?
Yeah, next. Yeah, imagine that secure random requires an argument. Can you use one of those properties that you defined before?
That is a good question to which I don't have the answer.
Okay.
You can just go to that try.kotlinland.org site and try it. Collections, well, because every language has to have its own collections. Actually, Kotlin doesn't really have its own collections. It only has views over the standard JDK collections. It doesn't have any collection class of its own. It just gives you different views over the standard classes. It just uses the array list and dash map and dash set. But the views it creates, it makes it a great distinction between mutable and immutable collections. You have both set and mutable set. Unlike Java, the Kotlin set is purely immutable. You can only get stuff from it. It also has some nice methods to create a new one with something else, or without some value. Or you can just use the mutable ones. Then the view is just the plain old array list that you have. They also have some nice utility methods, like they're planning to add, I think it's coming up on Java 9.
Yeah.
Where you can just do empty list of stuff, mutable list of stuff. You have to explicitly say that you want a mutable list. there's also a variant I didn't put here, mostly because of space. You can explicitly ask for an array list of. If for some reason you're using an API that requires that particular type, they also give you helpers for that. But this is most of what you'll use on a day-to-day basis. There's some weird stuff here on the map-off that's too thing. What that too actually is an extension function that's defined on any. That receives another any. Actually, it's generic and redefined, but what it does is that John 2 though is actually just a function invocation that gives you a pair of string to string, whose first element is John and the second element is though. So both map off and mutable map off, what they receive is a var of pair of stuff, and that stuff becomes the actual type for your map. This makes it much nicer than all the approaches you have to do in Java, or either that or the subclassing thing with the initializer, or having to declare map stuff equals map blah 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 blah. This makes it much nicer and allows you to easily create one-liner functions. The standard library also gives you some cool utilities. Some that are more functional like. Sorry, I didn't really talk about lambdas because it will require a lot of time, but that syntax over there it just receives a lambda, just like it does in Java, with a slightly nicer syntax. For instance, if the lambda is the last parameter of the method you're invoking, you don't need the parentheses. There's a lot of other languages that do just that. You have that extension function called apply, which receives the argument, the instance that's being invoked on as a receiver, and allows you to do things to it, and in the end returns the same thing. What this is great for is, once again, one-liner functions, when you can just instantiate something you want to return, and then you can just use apply to do all the things. You don't have to actually create the full body val client details equals base client details and blah 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 return client details. This allows you to make those transformations in a much more compact way. A new one that came out in Kotlin 1.1 is that take if. Basically, what that does is it evaluates that lambda. That's another form for a lambda, once again, just like in Java. And if that lambda evaluates to false, it just gives you null. That, coupled with Elvis and the safe navigation operators, allows you to do more compact validations without the need to chain ifs or to have all those nested null verifications. And I'm sorry about the time, I'm really just finishing up. Instead of the try with resources, you have this use method that is applied on auto-closable and does exactly the same as try with resources. It invokes that lambda, it just ensures that the thing is invoked on is closed. And then you have let, which is basically the map function you have in the usual more functional languages. This is called let and not map, because they do implement the map method directly on the collections, also as an extension function, and that would clash between the two declarations. And since all these extension functions from the standard library are imported automatically, they had to make this change to ensure there would be clash. I promise this is the last section. If you want to go functional, or at least if you want to build some, if you want to do stuff in a slightly different manner, they do have this concept of higher order functions. You can specify a lambda as a value just like you do in Java, and just pass it along, with the advantage that the compiler is smart enough that at least for the methods in the standard library that do receive lambdas, it knows that it doesn't actually need to instantiate the lambda, because it knows that the standard library methods will not treat the lambda as a value but just as code, and it inlines the thing, inlines the lambda. It doesn't actually need to create a new instance like Java does. That's the syntax for declaring that you receive a lambda. You receive a body. You just say, oh, I receive a lambda that receives nothing and returns something of type t. You can use that to implement a method such as this. Run that lambda within a lock. That return body parentheses. That's just the syntax for running the lambda. You just run it like this. You pass a lock argument, and you just pass your lambda. If you declare this do within lock function as what they call inline, the compiler will actually see that, oh, you're not using this lambda as a value. So when you put this in your code, it will actually inline all this and not create a lambda at all. It will just replace this return body with what's actually within the lambda. And that one makes Kotlin lambdas a bit more powerful and in most cases much more performant than Java's, even though they're making great strides in making it better. As I said, the standard library has most of the functional methods that you find. This is, for instance, the map class. You can call map on it. You can have destructuring of the entry. Because when in Java, for instance, you do for each on a map, you get the for each with entry key value. Since Kotlin 1.1, you can have destructuring of entry. So you can just do this and easily change all the values in this map to a string containing the key and the value. Functions with a receiver. Those are what's used to implement, for instance, apply. And this allows you to do something like this. Allows you to create some really nice DSLs. In fact, the guys over at Gradle, they have this project where instead of writing your Gradle build files in Groovy, you write them in Kotlin, because building DSLs is much nicer here, and it's statically typed. So take that as you want. And this allows you to create really powerful DSLs. This is a whole topic on itself that I really don't have the time to. I just wanted to show you a little bit of what can be done here. And that's pretty much it. This is, once again, just meant to be an introductory talk. I decided not to go too much in depth on any one given topic because there's a lot to see on all of those. I basically just wanted to show you some of the cool things of the language and to make you think how you can be more productive by using those on your day-to-day life. Questions?
I was thinking, if you want to do multi-thread programming, this is something I've never seen in Kotlin. Can you have synchronized methods? Can you synchronize on objects? Do you have volatile? Or
You have volatile as well. I'm not entirely sure about the synchronized. I think it works in a slightly different way, but I never really delved into it. And I know that in their guide they have a whole page dedicated to it, but I have the idea that it's not that different from Java.
so you declare like volatile var and then use it.
Yeah.
Thank you.
And one cool thing that they're adding in 1.1 that's still they declared that it's still in experimental is the support for coroutines and all that. So let's see what's gonna come up. Andy?
Right, so syntactic sugar, a bit of functional stuff. You see where I'm going, right? Why should I pick Kotlin instead of JRuby if I want a quick and pretty language? Besides, if I prefer static types instead of dynamic types.
Well,
I mean, safe navigation and all
That answer would be like one of those 2-hour panels that you find on conferences on people arguing about it. I don't really have a good answer for it. If you prefer JRuby, I'm not the one to say go to Kotlin. They're really two different things. The primary goal of Kotlin is not to say this is the best language in the world, this is the language you should use for everything. The primary goal is just to allow you to go from the Java that you already know if you're developing Java in your day-to-day lives, and you just want to be more productive and you want to have an easier time without much of an impact on your actual application. It's not something meant to be the all in all of programming languages. It's just another approach. If you like Java, you'll probably like this. If you like Ruby, I'm not going to be the one to tell you this.
With so much Scala inspiration, do they also have any plans to implement pattern matching?
I'm not entirely sure, but I don't recall actually seeing that. Once again, pattern matching it's something. It's almost a different, requires almost a different paradigm. It's not just a quality of life improvement over Java. It's something that's, let's just call it too different. They might do it in the future. I don't know, but I don't think there's any plans for it right now.
I don't see any collisions.
Did you run any performance tests with Kotlin in comparison with Java?
Yes, and we found out that there's pretty much no difference. Like I said, unless you're really doing some weird stuff, especially with reflection, because Kotlin's reflection is much more powerful than Java's, because they reify generics. They add metadata to the class that tells which then the Kotlin's reflection module knows how to read. So to reify the classes, so the bytecode itself is not reified, but the class has metadata. If you're doing stuff with reflection, it's more powerful than Java, so it's probably gonna be slower. But if you're just writing plain old code, you're not gonna have any issue. Because just like I said, most of what the runtime does is type checking and null checking. And if you're writing just pure Kotlin, you know that you're never actually going to pass a null there, so the JVM just erases that. And there's virtually no difference.
Maybe that's the answer to the JRuby question.
Maybe that's the answer to the JRuby question. Sorry, just to, I believe you wanted to know mostly about the runtime performance in terms of compile time. It takes about twice the time as Java, but it's still much better than say Scala, which takes about 10 times the time. So.
And it depends on how you write Scala a lot. The same amount of lines of code can.
Does it have a REPL?
Yes. Which I don't think I've ever used actually. But it does. Yes.
So I was thinking, what made you choose Kotlin instead of another more established language? And why jump to such a green language when, for example, Scala is much more established and has an ecosystem and basically all the features are there? And some more that you don't have to use, but they are there.
Yeah, we'll have to
Did you try it with another languages before choosing Kotlin? Because you clearly know a bit of Scala.
Actually not really.
I'll say you that you know it already.
I just know Scala pretty much from the comparisons that they make. But we have tried using Scala here at Talkdesk, not me personally. But what made us choose first, there's two sides of it. First, there's the Kotlin versus Java, just those two, and just Kotlin versus pretty much everything else. The Kotlin versus pretty much everything else is that, well, Kotlin just gave us what we needed, and the projects we especially needed some of the stuff from Spring Cloud, so we pretty much had to stay in the JVM ecosystem. And we didn't really want to delve that much into closure, despite some people here loving that idea. And we didn't really need any of the other features of, say, Scala. Also, you said that Kotlin was a green language. It's actually been around for 5 years now. I know it's not even close to Scala, but it's not that green of a language. It's something that's being used in production in a lot of places. So it's
And actually, Scala behaves pretty much like a green language because it's changing all the time.
Yeah.
And previous
But
versions of the runtime
there's
are
also-
incompatible
Did you
with
need
the
to
current
target
result.
Android or something like that? Would be a reason, maybe.
no, we're targeting Java 8.
And it's easy to go back, right? It can be
Yeah.
converted back into Java and converted from Java to Kotlin directly without automatically.
Automatically trademark, but mostly. The Kotlin versus Java, it was more of day-to-day quality of life improvements. We were having a hard time actually going to Java because of all that boilerplate, and Kotlin seemed like a good middle ground between having the power of Java and the performance of Java, but not having all that boilerplate and verbosity.
I have another question. What do you miss in Kotlin? You've written code in lots of languages. What do you miss?
That's always a tough one. RSpec. That's the answer. There's of course JUnit for test. For the ones who don't know, RSpec is the de facto spec/testing framework for Ruby. Of course, you can use JUnit, and we're pretty much just sticking to JUnit for now. We're waiting for JUnit 5 to bring some nice improvements. Kotlin actually gives you some nice idioms to work with JUnit. For instance, in JUnit 5, you can specify the full names for the test instead of just having to have that 1 mile method name. In Kotlin, as method names can have spaces and all that, it makes it much easier. We don't need JUnit 5 for that. But we're pretty much stuck to JUnit. There's some cool testing and spec frameworks that are Kotlin specific that are being built. Some of them actually buy JetBrains, but those are still not that popular and don't have all the support and all the features that JUnit has. But yeah, after doing Ruby for a while, I miss something like RSpec. And spec, they call it spec, the one that JetBrains is working on, actually gives you some really nice idioms, and it feels almost at home as compared to RSpec, but it's still not something that's that close.
How hard is Java interoperability?
Apart from the Kotlin specific features that you don't have, like the named arguments and default values, which, trust me, after getting used to named argument and default values is a pain, a huge pain, and we just a couple days ago, I really wished that specific class I was using was written in Kotlin. But oh wow, I just forgot your question.
Java interoperability.
Yeah, so, yeah.
How hard is it?
But if you forget all those Kotlin specific features, it's pretty much the same way you write in Java. You have all the libraries available. You have everything available to you. You can
So you can just import
Yeah.
interface into Kotlin.
you can literally pick a Java class that uses some Java library, copy it into IntelliJ. It will say, oh, this isn't Java. You want to convert it to Kotlin? It takes the semicolons and all the extra types, but everything else is exactly the same. And the other way around, for every Kotlin construct, actually they have in their documentation how you can invoke it from Java. So it's really, the interoperability is really easy.
Can you write your own Kotlinification library over your favorite plain old Java library, and how easy it is to do that?
Yes, you can, and actually you'll find that at this point there aren't that many Kotlin specific, Kotlin only libraries. You'll find that most Kotlin libraries are just Kotlin wrappers over Java libraries. There's one, for instance, for checksum, because as Kotlin has really 5 types, it makes it much easier to deal with all that serialization and all that stuff. There's one for JUnit as well to make it more Kotlin compatible, but those libraries are mostly just extension functions or type aliases that make it easier for you to do stuff. For instance, when is a keyword in Kotlin, and if you use the motif, for instance, when is the method you call to specify the expectations. So you have to put the right stuff around the when. And there's this Kotlin Mockito library that what it does is it simply creates a whenever method that just delegates to when. And that's about 90% of the Kotlin specific libraries, picking up Java libraries and making them friendlier to Kotlin.
How about checked exceptions? Do they get friendly in Kotlin?
Checked exceptions. Well, the Kotlin gods have determined that if you're writing Kotlin, you're probably a big boy and you know how to handle your checked exceptions. So you don't really need the compiler to do that for you. It's a trade-off, of course. But yeah, in Kotlin there's no distinction between checked and unchecked exceptions, so you don't have to declare anything.
So when you're calling Java code that throws in a checked exception, then you don't have to worry about it.
You don't have to worry about it. You can treat it as if it was an unchecked exception.
Okay, but will the compiler tell you something, or so?
Will IntelliJ tell you something?
So you have to care about it.
So
I have to care about it, but the compiler doesn't.
IntelliJ with
It's actually something weird because they're always trying to claim that Kotlin is safe, but they're always just saying, oh, that's not a problem. If you go at the documentation, it pretty much just says, oh, checked exceptions are just a nuisance, it's not a problem. And actually, if you go to more modern libraries, if you use, for instance, the latest versions of Spring is huge, and it pretty much has no checked exceptions. The trend in the Java world is to go away from checked exceptions anymore. So they just chose to cut them altogether.
Because so many people didn't know how to deal with checked exceptions anyway, so it's better to just let them propagate. Catching them and
Catch
logging
exception,
everything.
return it all. Is that better than doing nothing?
You can leave a comment there.
Also leave a comment here. Okay, so
Can you catch exceptions?
Yeah.
Can you put a
just like in Java. You have try catch, finally, try finally, just exactly like you do in Java.
No new.
No. You're just the only difference there is that there's no try with resources. There's only this use function and like the stuff. Yeah, this is pretty much it. But otherwise, try catch finally works exactly the same as Java. Okay, are we done?